Okay, guys, so we'll just be continuing from where we stopped in mathematics. Today we'll be treating mathematics. Last time I talked about logarithm in mathematics, and I was able to explain the laws of logarithm. So what I will be doing is a continuation of where we stopped last week, last 2 weeks or so. Yeah. So I will continue from substitution and equations in logarithm. How do you substitute in logarithm, and how do you solve for equations in logarithm? I will just be solving some examples. You know, the more you solve examples, the more you will tend to understand a particular topic in mathematics. So this example we have in here is given that log 2 base 10 is equals to 0.3010 and log 3 base 10 is equals to 0.4771. Calculate without using table the value of log 0. This is the question now. The value of log 0.72 base 10. So all you need to do is to bring this one out. So you bring log 0.72 base 10. So what we need to be doing here is, finding other terms we can use to, we can use to replace this, such that we'll have log 2 and what? Log 3. Because they only give us log 2 and log 3 as the value of log 2 and log 3. So how can we use this log 2 and log 3 as an expression, to replace this one? Yeah, that's what we should be doing. So first of all, for instance, let us try and convert this 0.72 first of all to fraction. Okay, if we convert this 0.72 to fraction, it becomes, I've taught you to convert numbers to fraction before, that is log base 10. 0.72 is the same as 72 divided by 100. You already know how I did that. What I did was I pretend as though I'm not seeing this point. If you're not seeing this point, I am seeing 72. So you write this 72 as the numerator, divide by this point, I change to 1, this one change to 0, this one change to what? 0. So this is equal to, now look at this. Now that I have already done this, remember the subtraction law of logarithm. Subtraction law says that if I have something like this, log A minus log B, right? Base, let me say base x and base x. According to subtraction law, it said I can pick one of the log and divide the powers. That is, if I have this, I can write it as log A over B base what? X. So if I have this, I can write it like this. It means if I also have this, I can also write it like this. So coming to this place, now I have 72 divided by 100 and I have log 10, right? So that means, it means I can also write this as this, log base 10, 72 minus, this will not be minus, this division comes to minus log, this will not be log 100 base 10. So according to that law, if I have this, I can also express it as this. So how can I break this down? 72 is the same. What will you multiply together that will give you 72? Numbers will multiply together that will give you 72. Let's say 36 times 2 will give us 72. 36 times 2 will give us 72. So why not use 36 times 2 to replace the 72? So we have this to be equal to log base 10. In place of 72, we now have to what? 36. 36 times 2. Right? Then this, we have it to be minus log base 10. Remember, 100 is the same as 10 squared 2. Yes. So we are having log. Now look at this log 36 times 2. I can also, applying the addition law, I can also express it as log 36 plus log 2. Remember, this is base 10 and this will also be base 10. Then this minus log. Remember that law that says that I can bring back this power. So if I throw back this power, it becomes 2 log 10 base 10. Yes, I believe we can still break this 16 down. 36. If we break 36 down, it becomes 36. 18 times 2, right? So we're having this to be equal to log. This 36, because of this 36, now have it to be 2 times what? 18, right? It's 36. Remember, it is base 10. Put it bracket plus log 2 base 10 minus. Now remember, logging into its own base is 1. So log 10 base 10 is 1. 2 times 1 will always give us 2. So we are left with this. If we are breaking this down, this log 2 times 18, I can also express it as log 2 base 10 plus log 18 base 10 plus log 2 base 10 minus 2. Yes. So let's continue. This is equal to log 2 base 10 plus 18 is the same as 3 times 9. 3 times 6. So we have this to be log 10. In place of this 18, it becomes 3 times 6. That is log 3 plus log 6 base 10. I believe you understand what I already do there. So this would definitely give us minus log 2 base 10 minus 2. Okay, let's go. So you have this to be log 2 base 10 plus log 3 base 10. This 6 is also the same as 2 times 2. So if I'm expressing this log 6 base 10 here, it becomes plus log 3 base 2 plus log 2 base 10, and this is also base 10 minus log 2 base 10. Remember there's minus 2 there. Minus 2. So all you need to do now, you see we have succeeded in breaking everything down. This is log 2 and this is log 2. This is also log 2. Log 2 base 10 minus log 2 base 10 will cancel out. This one cancels out this. So we are left with this, and this. So you have this to be equal to log 2 base 10. This log 3 base 10 plus log 3 base 10 will give us 2 log 3 base 10. Remember, there is still minus 2 here. So the next thing we will do is to substitute now. Remember from the question, they gave us what log 2 is. From this question, they said log 2 is equal to 0.3010. So we have this to be equal to 0.3010 plus 2. They gave us log 3 to be equal to, from the question, log 3 is equal to 0.4771. 0.4771 minus 2. So we have everything here to be equal to, if you multiply this, you have 0.3010. This times 2 will give us, we have 2 times 1 here will give us 2, 14. Write down 4, carry 1, 14. Write down 5, carry 1, 8, plus that one, 9.0. That is, if you use this to multiply everything here, this is what you would have, minus 2. So we have this, if we had everything here, 0.3010 plus 0.95. If you had everything, it gives us, let's just add. So let's say we have 0 here, 0.3010. If you had everything here, it gives us 2 plus 0 is 2. This is 5. This is 5. This plus this will give us 12. Write down 2, carry 1 point. So this becomes 1 point. Remember, we have minus 2. So if we subtract this from this, what will be our answer? We have minus something. So let's put our 2 here. Let's just subtract. 1.2552. That is 2 minus 1 point. So I can put 0 here, 0, 0. So look at what I mean. If you subtract this, this becomes 10. Borrow 1 from here, put it here, making 10. This is 8. This is 4. This is 4. This is also 4. This will now be 7. And this will be 0. So our answer, final answer is minus 0.7448. That is our final answer. So that is how you substitute in logarithm. Okay, the first example we solved is actually on substitution in logarithm. Also, I've shown the process how you substitute in logarithm. Just break the equation down and see how you can feature the things that was given to you in the question. You know, they will actually give you some the log of some certain number. So it is your own concern will not be how would you express that number such that you have those things given to those numbers in whose log you know, how you can actually express that question in terms of those numbers which you know they are logarithm. So now this other aspect is the equation. Okay, this is actually an equation, okay, in logarithm. This is base 10. So they said if log 2x plus 1 base 10 minus log 3x minus 2 base 10 equals to 1, we are expected to find the value of x. Now from here, look at this. I can apply, this is log base 10, log base 10. This is minus. I can express the whole of this as log base 10. This divided by this according to the rule of logarithm. So it becomes 2x plus 1 divided by 3x minus 2 equals to 1. Now I will express this one as log 10. 2x plus 1 over 3x minus 2 equals to. Now this log 1, remember logarithm to its own base is 1. I can express it as log 10 10 like this, because log 10 base 10, if this is base 10, just put log base 10 and you put what? You put, yes, log base 10, log into some basis is 1. So in place of this one, assuming this place was 2, that means I would have put 2 here as power, because if this 2, if you bring it back, if you resolve everything here to still give you 2, but it is 1. Log 10 base 10 is still 1. So in place of this, you put this. Now, the reason why I did that, so that I can actually cancel this log out. Base 10, log base 10, cancel the log base 10. So what am I left with? I am now left with 2x plus 1 all over 3x minus 2 equals to 10. So you see, this is a simple equation now, which we are expected to multiply. So you have this 2x plus 1 to be equals to what? If you multiply, you have it 10, 3x minus 2. So open this bracket, you have 2x plus 1 equals to 10 times the 30x minus this, give us 20. So if you do this, you're having 2x minus 30x equals to minus 20 minus 1. So if you subtract this, it gives you minus 28x equals to minus 21. Minus will cancel minus, so our x is equals to what? 21 over 28. That is our answer. That is how you solve equations in logarithm.